their reactances are equal. So here's a RLC series circuit. The voltage amplitude and the frequency of the source are 100 volts and 500 hertz respectively. So here's a series RLC circuit. The voltage is 100 volts, sine omega t. Omega is 2 pi f. F is 500 hertz. Respectively. R is 500 ohms, L is that, and C is that. What is the impedance of the circuit? Okay, so the impedance of the circuit is Z is for a series RLC circuit. The impedance is given by R square plus XL minus XC squared. And whenever you get problems like this, what you want to do is, first thing you want to do is calculate XL and XC. And you see, this is an impedance. This has the same units as resistance, ohms. These guys have the same units as resistance, ohms. And notice, generally in these problems, XL, XC, they'll be of the same order as that, okay, as the resistors. So if you don't get a number close to that, more than likely you're doing something wrong, okay? So let's do XC. It's 1 over omega C, which is C is 2 microfarads. That's 1,000. That makes it 10 minus 3. That comes to the top, so 10 to the power of 3 divided by 2 pi. So now we have all those values, so we can calculate Z. Z is R square plus XL minus XC square. $628. So the impedance of this circuit is frequency dependent, And at this frequency, it is that many ohms. Okay, and that's what we found. B, what amplitude? What is the amplitude of the current from the current source? So B, the amplitude I max is E max over Z. E max is the amplitude of the current is 100 volts. So the amplitude is 146 milliamps. If the EMF of the source is given by that, how does the current vary with time? So the EMF of the source is omega is 2 pi f, so 1000 pi t. What they're asking you is what is IT, which is I max. We've already found this. This guy is that. Sine omega t minus phi. So what they're asking you is this guy. This guy is that. So in this part of the problem, they're asking you that. And you know phi is tan inverse XL minus XC over R. XL minus XC is that. And you can see that this is slightly less than 1, so that's slightly less than 45 degrees. So 0.75 radians. So IT is 0.146 amps sine 1000 pi t minus 0.7.
Where's the 159 coming from? Is that
The
you change C?
XC, that's the impedance of the capacitor. Yeah, repeat the calculations, so we won't do that. Okay.
Can you go back just a second? Thank you.
All right, so again, an AC source, and we have RLC. For the circuit shown below, what are the total impedance, Z, and the phase angle between the current and the EMF? Okay. So there's the voltage source. Again, again Z. So we have R equal to 5 ohms. And you can see that F, this is omega is 100 and omega equal to 120 pi equal to 2 pi F. So F is 60 hertz. XL is omega L. So there is R, there is XL, and again you can see that this is of the same order as that. Yeah. Okay, so we have that. Now we can calculate the total impedance. So Z is equal to so the impedance of the circuit at 60 hertz is 5.73 ohms. And the phase angle between the current and the EMF. radian, and then write an expression for I. I max is E max over Z. E max is 170 volts. So that's what you're getting out of the wall. So, and Z is 5.73 ohms. So maybe this is a washing machine or something like that. That's the current amp. That's the current that a washing machine draws. So there's the expression for the current. Right,
Okay.